In section 2, we're going to look at an introduction to systems of equations. So we've talked about modeling a scenario with a linear equation. Now we're going to talk about a system, which is going to have two or more. So a system of equations is two or more equations that share variables. Okay. So some very common examples: supply and demand. You can have two or more equations that share variables. Rate and distance. When I was talking about comparison, like that's kind of an introduction to what a system is, and there's plenty of other ones. So when you have a system of equations, there are three methods you can use to solve. We have graphing, then we have substitution, and we have elimination. So graphing is great because you get to kind of visualize how the relationship between the two systems works together. You can see how they go. So substitution and elimination are the most common ways we solve a system of equations, mainly because it's algebraic. A lot of people are more comfortable with it. It's easier than graphing in some cases, depending on how complex your equations are. And you can hopefully avoid any fractions while doing substitution or elimination. So I'm going to do one example showing you how you can solve a system of equations using all three methods. So we have the system x plus y equals 3 and y equals 2x minus 9. So important thing about a system of equations is that there will only ever be one solution. So there's only one x and y value that makes both equations true. And that's what you're looking for in a system. You're looking for the one x and y value that will work for both equations. So when it comes to solving by graphing, they both have to be in that y equals mx plus b form. So that first equation, I'm going to subtract 3 from both sides and get y equals negative x plus 3. So now I'm going to graph the two equations, and I'm going to graph them in different colors. So I'm going to graph the first one in red and the second one in blue. So when you are graphing a linear equation, you start with the y-intercept, which is your constant. So negative x plus 3, I'm going to start at 3. And then my slope of negative x means down 1, right 1. And then I also go up 1, left 1. Connect those points, and that's my line. Second equation, 2x minus 9, I'm going to go to negative 9 on my y-axis, and then my slope is going to be up 2, right 1. I can also go, don't really have enough room to go down 2, left 1. Connect my points. So now when you're looking at the graph, the solution is their intersection. So you're looking for the point of intersection, which in this case, that's at the point for negative 1. And if I were to plug that in to check, 4 plus negative 1 equals 3, so we're good there. And then I'm checking that negative 1 equals 4 times 2 minus 9, which is 8 minus 9, which is negative 1. Okay. So now I'm going to talk about substitution and elimination. So this was graphing. Now for substitution. So the idea behind substitution is that you substitute one equation in for a variable. So the key idea with substitution is that you're looking for one variable to already be isolated. So either x equals or y equals. And in this case, I have that y equals 2x minus 9. So what I can do is plug that in for y in my first equation. And it becomes x plus 2x minus 9 equals 3. I'm going to combine like terms. I'm going to get 3x minus 9 equals 3. I'm going to solve for x, add 9. 3x equals 12. Divide by 3. I get x equals 4, which does match up with what we got when we graphed it, so we know we're on the right track. Now all I'll have to do is take that 4, plug it into one of the original 2 equations, and solve for y. And you might as well solve for the one where it's already isolated. So y equals 2 times 4 minus 9, which is 8 minus 9, which gives us y equals negative 1. Also just what we got when we graphed. So the last method we're going to talk about is elimination. So elimination, kind of like the name entails, we're going to eliminate one of our variables. Now, in order to use elimination, both my variables need to be on the same side of my equation. So the first thing I'm actually going to do is subtract that 2x from both sides so they're on the same side. So they have to be set up with x and y on the left side and the constant on the right. The idea behind elimination is, of course, eliminating a variable. Now, in order for the variables to eliminate, they have to have the same coefficient, which is the number in front, but with opposite signs. So one positive, one negative. And when you're looking to decide which variable to eliminate, there's 2 things I like to look for. One, if there's already a variable that's got opposite signs, and 2, multiplying only one equation in order to eliminate a variable. Now, sometimes you can't meet those. Sometimes you have to multiply both, and sometimes you have to multiply by negative. But don't add extra work for yourself. So if I'm looking, my y's already have the same coefficient. They're both 1 y's, and my x's are already opposite signs. One is positive, one is negative. So I have a choice here. I can either multiply that top equation by 2, or I can multiply one of the equations by negative 1. And I'm going to go ahead and I'm going to multiply this second equation by negative 1 so that my y's will cancel. So my first equation stays the same, x plus y equals 3. My second equation becomes 2x minus y equals 9. Then I'm going to add the equations together. The y's are going to cancel. We get 3x equals 12. Divide by 3, and we get x equals 4, just like we've gotten the previous 2 times. Now I need to plug it into one of my equations to solve for y. Go ahead and plug it into the first one. 4 plus y equals 3. Subtract 4. I get y equals negative 1. So all 3 methods produce the exact same answer, as they should have, because all 3 solutions should provide you with the same answer to the exact same system of equations. Let me know if you have any questions about solving a system of equations by graphing, substitution, or elimination.